if you see the results here, as mentioned before, we have three regions, but actually the solid region temperature is not so evident to say. That is because the solid region has very high heat conducting coefficient, but also very small thickness, and that is more evident when we plot the velocity. So this is the solid region, so the black area. Now in this part, we will try to simplify model by removing the solid region, but still keep a heat transfer between the two solids. So how can we do that? So looking back the problem description, so still two fluid categories and also transfer heat via a solid interface, and also the heat transfer itself and between the fluid and solid. And now we simplify the problem by this diagram. Here we don't build the actual solid region because it's 2 mm thickness. We just simplify at the interface between the air and water block. Now we have very simple or simplified problem description, and also if you still remember the key between of using the conjugate heat transfer is about split mesh region. So we will only have two regions of the computation. And now because we have this before and we can use it to build a simplified problem, of course you can also start from scratch, but use a simpler way than before. So my suggestion is, if you have, you can direct copy all the three folders. So now we are going to do here. I built a new folder for the demo, so called demo simp. I can copy all this, but except all these calculation results. So I'll still copy 0, constant, a system, and maybe also demo foam as well. So I will copy and paste here, and here to make it different, I will change the name to demo simp, right? So that is the folder we are going to work on. And the first, we need to modify the blockMesh dict. So we go to the system, so that word is, we are starting to work. So the blockMesh dict is here, and we need to modify it by using the new definitions. So I'll explain later about how it works, but I will just copy all here. This is a predefinition, this is a vertices, and this is a blocks. It looks much easier than the previous once you have the basic understanding. So what we do here, if you compare the graphs, what we are going to do is to build the two regions. We don't need the solid region, so all the main dimensions still the same, but we don't need the thickness of the solid. And also because we only need to have the 1, 2, 3 coordinates of the y-axis, so we don't need the fourth y coordinate, and also we only have the coordinate from 0, 10, and 20. So because we don't add the 2 mm solid thickness. Others are nearly the same, but here we don't need the solid region, so we also try to remove some of the coordinates in the final stage, and it's here we build the water block and we build the air block. So air block actually occupy the previous position of the aluminum block because the previous top region of the air will be removed. So that's all. That's what we need to do in the blockMesh dict. Also we need to define the boundary, right? So the boundary will be pasted here. So we also have the water inlet, water outlet, and the bottom walls, and also the air inlet, I believe. So here I copy the air. So the air inlet, the air outlet, top wall, front back. We also have the bottom wall defined as well. So there's no any change of the boundary condition except the solid two sides, right? And we also we don't need build the aluminum block, so the front and back face we also save a pair of that. So the front and back need to. So all these files are adapted from the previous definition. And if I go to the new demo scene folder, I should have all the files, and then I can run blockMesh to rebuild all the mesh files. And what I want to point out here, the special definition called here water and air. So because now I explicitly define the name for the air and water because there are two cell sets of here, and then I can directly use the split mesh region to build the files. So I don't need to redefine all the topology dictionary, and now I just need to do the blockMesh, and it should give me all the results. And then I will just run the split mesh regions to override all the existing meshes, hopefully. So split mesh regions, cell zone, and I'll need to override the right. So that should give me the two regions. If you see here, we have the two regions of water and air, and also the interfaces between the air and water. So that is quick demonstration of how we built the divisions